Yes. Yep. That's what today is. Today's a work day. So 1/16. Both days should be done by tomorrow. We don't have extra time, unfortunately, to kill. So what's the sine of 0? 0. What's the sine of 30 degrees? If you don't know, you will draw a little triangle and you will label it 30 degrees, 2, 1, up. Square root of 3, I did do it right. So what's the sine of 30 degrees? 1/2. Sine of 45 degrees. Now, this is 1, 1, square root of 2. 45. So it's 1 over the square root of 2, which is approximately 0.7. That's 0.5. What about the sine of 60 degrees? So square root of 3 over 2, what is that as a value? Somebody's got a calculator handy? Square root of 3 divided by 2 is 0.866. I know it is. Why do I know that? Did you wonder? Because I did a lot of it in college and grad school. We barely had calculators in grad school. What about 90 degrees? What's the sine of 90? Oh, that's 1. Okay, what's the cosine? The y-coordinate is the cosine of twice the angle. Well, twice 0 is still 0. What's the cosine of 0? Can't be 0. 1. Now, the cosine of twice 30 degrees is the cosine of 60 then. So the cosine of 60 is 1/2. Twice 45 degrees is 90. What's the cosine of 90? If you don't know, you draw the little cosine graph. There's pi. There's 90. Pi over 2. Just putting in values. That's all. Let me plug and check. Whatever. That's 0, right? What about 60 degrees? So the cosine of 60, which is the cosine, I have 2 theta, is the cosine of 120. So 120 is over here. So this is 120. So this is 60. I want the cosine. This is 2. This is 1. Square root of 3. What's true about the cosine? Is it positive or negative in this quadrant? It's negative. And if I do 90 degrees and I double that, that's 180. What's the cosine of pi? -1. So yeah, you could do this. You just graph the point. If I can slide it a little bit, we'll get my calculator out, but just ask to eliminate the parameter. We will need a trig identity. So we start at 0, 1. So x is 0, y is 1. So we're starting there. And when x is 1/2, y is 1/2. When x is 0.7, take that 1. Y is 0. When x is sorry, I didn't like my axes. Let me put a black axis. Fine. And you could look at your table of values right on your calculator. That's still crooked, isn't it? Oh, yeah. Okay, that'll be better. Okay, 0, 1. It's right here. Here, make that 1. 1/2, 1/2. 0.7, 0. 0.8, -1/2. And at 1, I'm at -1. So it's going to look something like that. You could keep going around, see what happens. Or we could eliminate the parameter. Sometimes it helps to see that. Keep in mind what's going to be true about your domain. The sine of theta is going to be between what 2 values? 1 and -1. So your x's won't get any bigger than that. What about your cosine of 2 theta? Not squared, between 1 and -1. So my domain is going to be between 1 and -1. Kind of looks like maybe a circle, maybe something like that. Well, let's do the eliminate the parameter. I need to know what the cosine of 2 theta is. I'm going to put my graph right here. X equals the sine of theta, and y equals the cosine of 2 theta. Isn't that cosine squared of theta minus sine squared of theta? I don't know if that's the one I want, or if I want, there's another one. So I get out my little trig identities, and sine of theta is x. So where I see sine of theta, I'm going to put in an x. Oh, that doesn't look, see, I don't know what was going to happen here because I didn't do enough points. This is an identity. If you look on the inside of the cover of your geometry page, please try to keep this intact, although I'm tempted to pull it out. You know, maybe I should pull it out and get it laminated, and then you can hand them in to me at the end of the year. It is. It's underneath the double angle formulas. Yes. I can't do anything with this. That's a trig identity. The whole point of identities, first, the original point was we had to look everything up in tables. So that's why you did changes. Well, now you don't have to look at them in tables, you use your calculator, but there are some things like eliminating the parameter here where a trig identity helps me. And so it's this. I chose to go totally to the sign because even when I wrote this one, I didn't know what to do with it. What do I do with that? I could square this, but that still doesn't help me with the cosine. So, I mean, those are just some tricks to do. So I said, well, let's just get it all in terms of sine, and I know that the sine is x, so I can just put that in there. So I know what that looks like. It's a what? It's a parabola starting at 1. And which way does it point? Going down or up? Going down. Except that you have to be careful. It stops there. And my guess is it stops there. It starts, because we just did a table of values, we started at 0 at least. It goes this way, it's going to come back this way, come back down here, and then it's going to go back up. Well, let's see if that's really the case on my calculator. So there are advantages to having the 84. Here's one of the advantages if you want to see the motion. So I'm going to quit, just get out of there, make sure everything's clear. And I am going to go to mode, and we're going to go to parametric. I don't know that it's easier. I find that the parametric on the Inspire is a little bit cumbersome because every time I want to do a parametric graph, I got to go back to the menu. And I don't have an option of trying to see some motion there. Now, one of my friends gave me a little program, an app that does that. I haven't figured it out yet, but maybe I'll figure it out by tomorrow. Okay, so now I'm going to go y equals, and there are your two equations. I have sine of theta, and you could do t, it doesn't matter, sine of t, and the other one's cosine squared. You're going to have to put parentheses cosine of t, parentheses squared. And then the hard part is the window. I'll go from 0 to 2 pi. T steps 0.13 is pretty much set like that on the Inspire. The x min, x max, that all looks pretty good. It's a trig window, so I don't see any point changing it. And graph. Okay, I'd like to see that a little bit better, except that, wait a minute, didn't I get to -1? Oh, what did I do wrong? Do you know what I did wrong? Oh, no, cosine of 2 theta. Oh, I put cosine squared in. That's what I did wrong. Nice. Check me on these things. I can do cosine squared minus sine squared. I goofed. That was cosine of 2 theta. Goof. Cosine of 2 theta. There we go. Now I'll be happier. I'm going to fix this a little bit. There, that looks better. Now I'd like to see it. So how can you see it better? First off, I want to change my window. I don't want it so big. So I'm going to go from -2 to 2. Mrs. Hurston doesn't have this luxury yet. And we'll go -2 to 2. And we're going to change our step size to be 0.05. If I go to 0.01, it's going to be too slow. 0.05. And now I should be able to see my motion when I graph. There it comes down. Oh, and you know, I still can't see it very well. And unfortunately, there is no option like I have here. See, this is what I was talking about, the circle trace. Change that so we can see it. There, the little circle with the line after it. Now if I graph it, and it'll go slower. It always goes slower when I do that. And not only that, you can see the velocity because it has to stop. So my guess is its maximum speed is at the top there, and now it's going to stop, slow down, and then it's going to start up again, and it's going to speed up. Kind of cool. And I can't get that picture. You want me to do it again? I will. I can't get that picture on the Inspire. I did ask, and this guy knows everything there is to know about Inspire. It's not possible. I will talk to TI and see if they will fix that issue. Because to me, that's a problem. So let's look at that again and see if you can see the speed. Now, all you have to do is rekey the T, and it will graph again. See how slow it is? Now watch it. It's got to slow down, so it has to stop, turn around. Now it should be speeding up. Is it going faster? Looks like it's faster to me. Watch, it's going to slow down because it has to stop. You can't just go from 20 miles per hour to 0 now without smashing yourself. It has to go through all those speeds. So that's kind of cool. And look at your domain. Okay? Best you get up here is 1. And this is at -1. That's fine. -1, -1. Because the question, everybody needs to listen because I'm going to quiz you on this. You know that. Okay, do you hear me? Guys, you need to listen. If you're talking, you're not listening. I expect you to know the domain, so it will happen on the quiz. This is new material. Why is the domain trapped? Because x is defined as the sine of theta. The real equation is not this one. That's the Cartesian one. Okay, girls in the back? This is the Cartesian one, and this picks up every value with the parabola. But my function was not defined as y equals 1 minus 2x squared. It was defined that the x-coordinate would be the sine of the angle, because I rotate around this, the axis here. So my angle's 0, then x is the sine of 0. Same with the cosine. So what's the biggest the x value can be? 1, because it's defined with the trig function. Had it been a tangent, tangent can go to infinity, so it'd be fine. But it's not tangent. So that's what you have to think about. So you need to check your answers. And I need to get mine going, but I've had some problems that I haven't been able to get to. I'm trying. Okay, I don't know if there's other questions or just let you work. Work works for me. Then maybe I can start getting caught up too. And I'm going to